There are three methods of solving simultaneous equation. They are elimination method, substitution method, and graphical method. But in this video, we are concentrating on elimination method. Check out the description and playlist for substitution method and graphical method videos. How do you identify simultaneous equations? Simultaneous equations usually have two unknown variables. When we have three or more unknown variables, we use other methods like matrices, which is beyond the scope of this topic. To explain how to identify and solve simultaneous equations, let's start with a simple linear equation with only one unknown variable. The aim here is to make x the subject. We are going to have 2x equals 9. Here we have minus 5. It will move across the equal sign to become plus 5. 2x is now 14. We want to isolate x by making it the subject. X is now 14 divided by 2 because 2 is multiplying x, and a multiplying variable moves across the equal sign, it will divide. X is now 7. Remember that when a multiplying variable moves across the equal sign, it will divide. Also, if a dividing variable moves across the equal sign, it will multiply. Likewise, if a variable is adding, on the other side, it will subtract. It will become a minus. And if a variable is minus and it moves across the equal sign, become plus. We can solve this, which is pretty simple because it's a linear equation with only one unknown variable, which is x. Let's consider 2x plus 3y equals 8, where x represents the number of doors in a building and y represents the number of windows in that same building. Solving this one linear equation with two unknown variables, x and y, is not possible unless we decide to put that x is equal to 0 to find y. Afterwards, we'll now put that y is equal to 0 to find x. However, using this method do not always give us an accurate result. We are going to need an additional information regarding similar doors and windows in x and y variables. The second building has an equation of 2x plus y equals 4. Now you can see we have two equations to solve simultaneously. For these two equations, here we are now going to have equation 1 and this is equation 2. The first step is to ensure that the x for equation 1 and the x for equation 2 are vertically aligned. Also, ensure that the y at equation 1 and the y in equation 2 are also vertically aligned. The constant on the other side of the equal sign. The constants are the numbers without x or y. Next, let's consider the coefficients of x and y. Now, in equation 1, the coefficient of x is 2 and the coefficient of y is 3. For equation 2, the coefficient of x is 2 and the coefficient of y here is 1. Whenever is 1, we don't usually write it. The coefficient of x for equation 1 and the coefficient of x for equation 2 are the same. Hence, we're going to subtract by elimination. 2x minus 2x is 0. 3 minus 1 will give you plus 2. 3y minus 1y is 2y. And 8 minus 4 is 4. Next, we're going to have that 2y is now 4. Y is now 4 divided by 2. And y is now 2. You see, we have obtained that y is 2. Next, we're going to substitute y equal to 2 into equation 1 or 2. Here, I will substitute into equation 1. Equation 1, we have that 2x plus 3y is 8. We have y, so this is 2x plus 3, and instead of y, here y is 2, and this is 8. Next, I will have that 2x plus 6 is now 8. So 2x is 8 minus 6, and 2x is now 2. X is 2 divided by 2, and x is 1. You see, we have that x is 1 and that y is 2. How do I know if my answers were correct? The last step is that you should check and test for accuracy. And how are you going to do this? Let's test for equation 1. 2x plus 3y. For x, we're going to put 1. Then for y, we're going to put 2. This gives us 8. Next, for equation 2, we have 2x plus y is 2. And for the value of x, we have 1. And this gives us 4. We have this as equation 1, and we have this as equation 2. The coefficient of x in equation 1 is 2, and the coefficient of x in equation 2 is 4. They are different. The coefficient of y in equation 1 is 1, and the coefficient of y in equation 2 is also 1. Remember, when it is 1, we don't usually write it. Since the coefficient of y are the same, hence I can eliminate one of them. However, I'm not going to use a minus because one of the y here is having a minus. Let me just make this mistake of using this minus. We're going to have that 2 minus 4 will give you minus 2x, y, which is plus y, minus, then there is a minus here, y. And you're going to have that y minus times minus is plus y. Y plus y will give you 2y. Here I'm going to have plus 2y. On the other side, 8 minus 4 will give you 4. You can see that we still have two unknown variables, which have defeated the purpose of elimination method. Hence, instead of minus, we're going to use a plus. Now, let's solve this correctly. 2 plus 4 will give you 6x. Y plus minus y. Y plus minus y will give you y minus y, which is 0. So here we have 0. On the other side, 8 plus 4 will give you 12. And here we're going to have that 6x is 12. X is now 12 divided by 6, and our x is 2. So we have obtained the value for x. Next, to find y, we're going to substitute that x equal to 2 into either equation 1 or equation 2. Well, let me choose 1 or equation 2. Well, let me choose from equation 2. We're going to have that 2x plus y is 8. 2, our x is 2, plus y is 8. Here, we now have that 4 plus y is 8. Y is 8 minus 4. And you can see that y is now 4. You can see that using elimination method is simple. When the coefficient of x or the coefficient of y are not the same in equation 1 and 2, how can we eliminate one of the variables to be able to get the other one? Next, in this simultaneous equation, this is equation 1 and this is equation 2. From equation 1, the coefficient of x is 2, and in equation 2, the coefficient of x is 1. They are not the same. Also, in equation 1, the coefficient of y is 1, while the coefficient of y in equation 2 is 3. They are not also the same. What are you going to do in such a situation? You can decide to use the coefficient of x, or you can decide to use the coefficient of y. In this problem, I'm going to use coefficient of x in equation 1 to multiply everything in equation 2. The coefficient of x here is 2, and I'll multiply everything here by 2. The coefficient of x here is 1, so I will multiply everything in equation 1 by 1. So with this now, we have 1 times 2 will give me 2x. 1, this 1, multiply by 1 will give you 1y. And this 1 will multiply this will give you 10. Next, 2 times 1 will still return 2x. 2 times 3 here will give you 6y. And 2 times 5 will give you 10. Now, we have that the coefficient of x in equation 1 and the coefficient of x in equation 2 are now the same. Hence, I will subtract. Next, minus y minus 6y. Minus y minus 6y. You're going to have minus 7y. Hence, we're going to have minus 7y. Next, 10 minus 10 is 0. So you're going to have minus 7y is 0. Y is now 0 divide minus 7. 0 divide by any integer is 0. 0 in mathematics is allowed to divide any number. However, no number is allowed to divide 0. That is, any number divided by 0 is undefined. It's not allowed in mathematics. This is not allowed in mathematics. However, 0 can divide any number, and 0 will reduce that number to 0. Next, let's find x. Now, from equation 2, x plus 3y is equal 5. X plus 3y equals 5. X is now 5 minus 3y. I know the value for y. So x is now 5 minus 3 because y is 0. And 3 times 0 is 0. And here x is 5. Now that we have obtained the value for x and for y, next we need to test for accuracy. We're going to substitute x equals 5 and y equals 0 into equation 1 and equation 2 respectively. For equation 1, you are going to get 10, and for equation 2, you are going to get 5. Next, let's consider this question. The first thing you're going to look at is that x in equation 1 and x in equation 2 are aligned. Likewise, y in equation 1 and y in equation 2 are aligned. And on the other side of the equal sign, there is no x and y variables. Next, let's consider the coefficient of x here in equation 1 and 2. Their coefficients, they are not the same. Next, consider the coefficient of y in equation 1 and the coefficient of y in equation 2. They are not also the same. Hence, what are we going to do? I will take the coefficient of x, which is 3, and multiply everything in equation 2. I will take the coefficient of x here in equation 2, which is 5, and multiply everything in equation 1. Next, I will draw a line. 5 multiplied by 3 will give you 15x. Next, 5 multiplied by 2 will give you 10y. Next, 5 multiplied by 7 will give you 35. Next, for equation 2, 3 multiplied by 5 will give you 15. Next, 3 multiplied by 3, here we have minus 3, so we're going to have minus 9y. On the other side of the equal sign, 3 will multiply 37 and you're going to get 1, 1, 1. Next, what have we achieved? The coefficient of x for equation 1 and 2 are now the same. Hence, we're going to subtract by elimination. 15x minus 15x will give you 0. We have eliminated x. Next, plus 10 minus 9y. So here I will have plus 10y minus then minus 9y. I'm going to have that 10y minus times minus is plus 9y. So at the end of the day, we're going to have what? 19y. So here I'm going to have plus 19y. Next, on the other side, I'm going to have 35 minus 111. Here I'm going to have minus 76. Next, y is now minus 76 divided by 19. And now we have that y is minus 4. Next, we're going to substitute the value of y into either equation 1 or equation 2. And here, I'm going to use equation 1, where I have 3x plus 2y is 7. I know the value for y, so I will have that 3x plus 2. Instead of y, I will have minus 4 is 7. Here I will have that 3x minus 8. 2 multiply minus 4 is minus 8 is equal to 7. 3x is 7 minus 8 will move across the equal sign to become plus 8. 3x is now 15 and x is now 15 divided by 3, and you can see that our x is 5. You can see that x is 5 when y is minus 4. The next step is to test for accuracy by substituting x equals 5 and y equals minus 4 into equation 1 and equation 2. Let's consider this question. Before we solve this, firstly, we're going to check if x and y in equation 1 and 2 are vertically aligned. Here we have that in equation 1, 5x minus 3y, on the other side we have minus 1. But in equation 2, we see that we need to rearrange. For us to have 2x, this minus 4y we need to move. On the other side will become plus 4y. And on this side, I'm left with 6. Now that the equations are rearranged, next, let's start solving. Next, we're going to consider that the coefficient of x in equation 1 and 2 are not the same. Likewise, the coefficient of y in equation 1 and 2 are not the same. Hence, I will use these 2, which is the coefficient of x in equation 2, to multiply everything in equation 1. I will use this 5 in equation 1 to multiply everything in equation 2. Next, 2 times 5 is 10x. Next, 2 times minus 3 is minus 6y. Next, 2 times minus 1 is minus 2. Next, 5 multiplied by 2 will give you 10x. 5 multiply 4y will give you plus 20y. And 5 multiplied by 6 will give you 30. Next, you can see that the coefficient of x in equation 1 and 2 are now the same. Hence, we're going to subtract by elimination. 10x minus 10x is 0. Minus 6 minus 20. You're going to have minus 26y. On the other side, minus 2 minus 30 will give you minus 32. Next, y is now minus 32 divide minus 26. Minus at the numerator will cancel this minus at the denominator. Y is 16 over 13. Now we have obtained the value of y. Next, let's solve for x. Here, I'm going to use equation 2. From equation 2, where I have that 2x plus y is 6. 2x plus 4, y have a value. Y is 16 over 13. I have that 2x plus, this is like over 1, 4 multiplied by 16, 64. Next, 1 times 13 will give you 13. And on the other side, we have 6. Here, I have 2x. On the other side, I have 6. 64 divided by 13 will move over to the other side and become minus 64 over 13. Next, remember, this is like over 1. What we're going to have here, this is 2x. And on the other side, I'm going to have 13 multiplied by 6. I will have 78. Next, I will return this minus. Next, 1 will multiply 64. Remember, I went like this first, then like this. Next, at the denominator, 1 will now multiply 13. And we're going to have 13. I have 2x. Here, I have 14 over 13. I want to isolate x. 2 is multiplying. On the other side, 2 will divide. And you're going to have 14 over 13 multiplied by 2. And the final answer here is 7 over 13, which is our x. You can see that x is 7 over 13. You know that 2 here is 1 and 2 here will become 7. Next, we need to check for our result. We're going to substitute 7 over 13 for x and 16 over 13 for y into equation 1 and equation 2. If you substitute into equation 1, you're going to get minus 1. If you substitute into equation 2, you are going to get 6. Can we use substitution method and graphical method to solve all the problems you have seen in this video and still obtain the same result? The answer is yes. But there are exceptions to some questions that involves a linear equation and a quadratic equation, or a linear equation and equation of a circle, for example, which we can solve by only using substitution method or graphical method. If this video was helpful, please hit the like button, subscribe for more videos like this. I will see you in the next video lesson.